Hello, Porto. I love saying that. It's complete rock star up here with a handheld microphone going, yes, I'm Bill Hicks. I was at devox last week in Belgium, which you probably just go, what's devox? It's a Java conference, because I've started doing talks that are not just about Microsoft and .NET. Now I get invited to go to Java conferences, and bless them, it's a very different culture. You know, people go, oh, .NET's all enterprise. Java is like, they've just lent into that whole thing. And the talks, they've got a 15-minute break between talks, and people are queuing up outside. I mean, like proper, like 40, 50 people standing in a queue, waiting to go in before the people have come out from the talk before. And you kind of like turn up 10 minutes before you're supposed to, and just the entire room sat there watching you have problems with your HDMI cable. Anyway, I've brought you here today to ask the question, how simple is as simple as possible? Because I don't know exactly how simple that is. I do know it's a lot simpler than all the stuff that we're doing at the moment, and I would just like to talk about that, if that's okay. I am expecting some reds. I am also probably going to tell you that you don't need to use something that you've just seen a talk about that looked really cool. So I'm going to be like and then I'm doing the fun talks, and so you can all come and heckle. So yes, I have been doing this since 1990. My first job, I was barely 17 years old, and I worked for a local software company in the town where I grew up, and they taught me C and this thing called Infomix ESQL-C, which was like a way of putting select statements into C code. You surrounded it with dollars, and you put into variables, and then it would generate the equivalent CISAM code. I found it hilarious when Microsoft invented Link in like 2010 or whenever that was, because yeah, that was what I was doing. And then we upgraded from ESQL-C to a thing called Infomix 4GL. We were building software that ran on Unix boxes, or Xenix boxes actually. Our dev box was a Tandem 286. I think it had 4 megabytes of RAM and something like 100 megabytes of hard disk that you could literally break somebody's arm with if you threw it at them. And you connected to it over RS-232 cables, and part of my job was to make those with a soldering iron, and you have to trust me because nail polish now, but there is a soldering scar under that nail there. And this is a Wise 50, Wise 60, VT something, I don't know. But it is a monochrome monitor, and it has 80 columns and 24 rows, the bottom one of which is not accessible through the operating system interface. And we wrote code for this. We wrote complex systems, data, logistics, retail, all the things. Everything ran on this. And we didn't have the internet. We only had the internet. We had Usenet. I was busy arguing with people about the existence or otherwise of various gods on Usenet over the internet. But the World Wide Web hadn't been invented. So this was the documentation. And these were ring binders. And people would come and they would get the ring binder and they would find the bit of documentation they needed, and they would pop the rings and they would take it. And then they would run over here, and then it would never come back. And so we used to have to order new ones of these about twice a year. But this, in its entirety, is the design. This is the HTML and the CSS. Okay, this is the front-end code of an Infomix 4GL database program. That's the front end, all right? This is like your JSON mapping or something. This is your GraphQL. This links the fields on this form. You see we've got customer ID F0 and title F1, and then, wrong button. And then in here we go F00 is customer.custID. We just go, that field is that column in that database table. And then this it put it into what they called query by example mode, and the user could enter sort of criteria in the different fields. It required them to know the wildcard syntax of the Infomix database, which was asterisks and question marks. And sometimes you'd have to retrain people who were used to Oracle, where it was like percent signs and something else. But this, and then we construct by name. That one line of code, broken over several lines, constructed a SQL query based on what the user had put into the fields. Then they would somewhat counterintuitively press escape on the keyboard, and then the code would resume here. So your code, you went construct, and it basically handed control over to the user while they entered the things in the fields. And then it would return when they'd finished, and you would just say, select star from customer where, close quote, SQL injection attack. But of course, there was no such thing as a SQL injection attack, because the only people who could access this were people who had access to a WISE terminal that was connected to a Unix server by an RS-232 cable that I'd nearly died making. And so, yeah, good thing. Prepare a statement from the SQL, declare a cursor for the statement, open the cursor, fetch the cursor into a record which is defined up at the top there. So yes, that's the entirety of, this is the ORM, this is Entity Framework, this is your API, this is your back-end code, this is everything. And yeah, this guy, I love this guy. This was happening. I was literally sitting on the sofa with my laptop working on this talk, and this dude pops up on the television, the Turkish entry in the pistol shooting. And you have to understand, that's what most of them look like, okay? What even is that? There's like, I think for some reason, that person has a honeycomb sticker on their left lens of whatever those are, and all this sort of thing. And this guy just turns up and picks up the gun and goes, pum, pum, and gets a silver medal. I love him. I love him. You don't need all that stuff. You just need to be good at what it is that you do. So, what is about to follow for the next 45 minutes, 55 minutes, is opinions. My opinions, because I have a microphone and you don't. But yes, this is just what I think. I am not an expert. I am not a thought leader. Dear God, I am not a thought. Please do not let me lead your thoughts in any meaningful sense. I'm an idiot. If you disagree with me, that's okay. If you do disagree with me, I would encourage you to engage with me on the website formerly known as Twitter. That's the best place to disagree with me, because they've just changed the way the block function works, and so I'm not using it anymore. So yeah, feel free to try and start an argument with me on Elon Musk's Hell site. I don't actually need to be there, because if you disagree with me, you're wrong. Yeah, this was the best image that came up when I did a Google image search for KISS. But no, KISS, in English, that stands for Keep It Simple, Stupid. And this just raises the question, keep what simple? What is it in this context? What is it that we are all doing every day, Mark, that you would like us to make more simple? And it is literally everything. It's the way you are designing and I'm going to put this into the second person, make it more combative. No, it's the way we are designing and architecting our systems from the very first sort of ideation point. It's the way we're building APIs. It's the way, definitely the way we're building front ends. It's the way we're managing our infrastructure and our external services, the platform services that we're using from Azure or AWS or Google Cloud. And then layered on top of that, it's the processes that we're using to try to ensure that we do all those other things properly in terms of meetings and code reviews and all that sort of thing. So I'm going to go through them in order, and we'll start with design and architecture. Because the design and architecture of those old Infomix systems, there was no choice. It was running on a shared user environment, and it was literally just sending ASCII characters over a cable that appeared on the screen. The refresh rate was like 1 frame per 2 seconds or something. And so it was kind of necessarily a monolith. The early systems were monoliths. Mainframes were kind of it was this really weird mix. They were monoliths because everything's running on this one big machine that is just scaring people in the corner with all the lights. But actually on the inside, mainframes are like really complicated systems of messaging and microservices and everything else, and yeah, let's not go there. But your average system back in those days was a monolith. It was a single piece of code. It took 2.5 hours to build systems when you have a Tandem 286, and it has to compile from Infomix 4GL, which is that language that I showed you. It actually compiled from that into the ESQL-C that we had stopped using. It then compiled that into C, it then compiled that into object files, and then it had to link all those object files into a binary, and then you would find out if it worked. We had a table tennis table. I got really good. You're not doing that twice. You're not breaking, I think we should break this down into 2 systems, because honestly, halving the number of lines of code doesn't halve the compile time. It's just a law of C. But yeah, so we were building monoliths. And then we were quite happy building monoliths, building big sort of ASP.NET applications or Java Server Pages applications, and it just did everything. You needed to add functionality, you added a new page. You needed to add a cross-cutting thing. You made a code change in one place, and it affected every single part of the application. You just set a global variable or stuck something in a session. And we made this work. We made software that people used, and they did their jobs, and then they went home, and they were happy. And then we went, oh, but what if the company that I work for that sells sprockets to mechanical repair garages in the southwest region has the same problems of scale as Uber? What if every method in our system was a separately hosted microservice? And so we have this inability for Martin Fowler to create a new page on his Blicky without tearing the entire industry down and rebuilding it again in a new image. And microservices, they're fantastic if you have the problem that microservices solve. And the problem that microservices solve, or the problems that they solve, is thousands of developers and working in disparate places and on entirely different bits of the system. And that's actually the biggest deal with microservices, is the number of people who are building what comes together to form one great big system. If you've got 100 programmers, you don't need to be doing microservices. If you've got less than 100 programmers and you're doing microservices, and you're still doing it in a year, I will literally find out where you live, and I will come round and I will kick you really hard in the shins. I'll put like steel toe-cap boots on to do it. But we got into this situation where everybody went, we're going to do microservices, refactored everything into microservices. I was at a job, I'm not going to name any names, and I have a reputation of kind of this, I don't do this nonsense, I just do stuff that works and fix things. And I got parachuted into this project that had been trying to ship something for 2 years. One team, about 8 people, 17 GitHub repos. And 3 of them were NuGet packages, and the other 14 were microservices that they had broken their microservice down into, and at least 5 of them had to be deployed in concert at the same time, otherwise everything broke. And so I spent, like, I think 4 weeks with them. We got it down to 1 GitHub repo, 2 Visual Studio solutions, and they shipped it 2 weeks after I moved on. So yes, microservices maybe not the best idea for everybody. And this is what most people, the thing where you kind of go, these have to be deployed together, and if I change that one, I'm going to have to change these 5 and all this sort of stuff. That's not a microservices architecture. You've just broken a monolith in the same way as I would break a plate by dropping it on the floor and then going, ha-ha, micro-crockery. And you think you've done something right. No. And so rather than letting people build distributed monoliths, sort of realizing that was a bad idea. I don't know what happens. Is there like an Illuminati or something? And Martin Fowler brings them all together and sits at the head of a table and goes, modular monolith. And then they go, yay, and they run out. And then that's the thing, we have to tear it all down and build it again. Because the thing is, the nice thing about modular monolith is what it's basically saying is, remember those things you did that were quite easy and they worked? Just build them a bit better. Yeah? Just single responsibility principle, keep your classes clean, introduce new classes if you need stuff, use dependency injection. The idea of the modular monolith is that if you have a part of your system that is experiencing weird scaling issues as the number of auto mechanics in the southwest region increases and they need more sprockets, then you can hive that bit off really easily. And people have different ways of doing this. They put different sort of vertical slices of functionality into different Visual Studio projects. It doesn't really matter how you do it, but all modular monolith means is that thing we were doing that worked, but the code was rubbish, do that again, but with better code, all right? That is simple. Just build the software, all right? Sit down, figure out the simplest, easiest bit of it that you can do, and then do it, and then do the next bit, and then architecture and design will emerge along the way. You know, obviously you've got to make some choices about platform and that sort of thing, but as far as the code is concerned, just create a single API endpoint, and then ship it, and then build the next one, and then build the next one. And as you start to get more code, it's like coming home with a book. Like you've had a house fire, and you come back, and they've rebuilt your house, and they've rebuilt all the furniture, and the bank has paid out the insurance money, but your precious collection of books has been destroyed. And so you come back, and you've got this one book. This is the first book of you starting to rebuild your collection, and then you come in, and then you build one of those complex systems of kind of rolling shelves that they have in the basement of the CIA to store your single book in. Because you're going to need it in the future. That's the thing, we're going to need it tomorrow or the next day or the next day. You're not. You're almost certainly not. You're probably not. You can always quit. And design and architect, this is the kind of upfront thinking that people insist we're going to have to do. And if you hire ThoughtWorks, it's going to be DDD. That's what ThoughtWorks do. They will come in. I worked at a place, they had a web bug, a tracking pixel, you know, the invisible pixel, and it sets a cookie, and then it follows the user across all the pages so they can map it out. And some ThoughtWorks consultants had implemented that using DDD and event sourcing. It was a Visual Studio solution with 8 or 9 projects in it, and I couldn't find a single one that persisted data anywhere, because it was all magically done with configuration when they deployed it. And it didn't work, and I replaced it with 100 lines of JavaScript in just a little Node.js microservice thing. And the only bit I had to do, the only bit that made that complicated is that JavaScript is rubbish at generating UUIDs. And I couldn't get any of the native things to work. And so I deployed what I think was the first production ASP.NET Core service outside of Microsoft, because it was Project K, version 0.5. And all it did was generate UUIDs. You hit it with an HTTP request, it just went type text/text, it's a UUID, just so the node system could scale. But no, so you can do domain-driven design, but ideally, domain-driven design would be something where you're sort of just writing your nice, clean code, and then you kind of, at some point, it dawns on you, you go, I'm doing domain-driven design. That's quite good. What domain-driven design does not entail, ever, is base classes called things like aggregate or bounded context, all right? You don't just take the words out of the book and name types after them and think you're doing the thing, all right? CQRS, again, it's a nice pattern and it makes sense in a lot of circumstances. It's a thing that you should know exists so that when you sit down to solve a problem, you go, well, if I do the command and this thing and then have a completely separate bit that is for reads and I can do such and such in the background. And then we stick event sourcing on top of that or event driven. I'm sure, is there someone in this room who could actually explain to me the difference between event sourcing and event driven? And is it, with event sourcing, you keep all the messages, and then the idea is that you can replay them all? And it's only a matter of time before someone says that should be done on blockchain. So yeah, no. Just build it. Just build the bloody system. Sit down, start coding, do your whiteboarding sessions. You know, identify the endpoints that you need, the functionality that you need. If you need a database, then go, database goes here, and then decide which one you want to use when you're actually getting to the point of knowing what the data looks like. Just build stuff, and then keep the code clean, and then if it goes wrong in some way, refactor it, break it into pieces, put pieces together, do what you want, just build it. APIs. So many ways of doing APIs, and like I say, I've been around for a long time. I remember when this was the hotness. This is SOAP, and approximately, I'm going to say 10 to 15% of the characters on that screen are data, and the rest of it is SOAP. And yeah. This is still very, very widely used. I have worked with SOAP. I'm working with essentially SOAP formatted XML but being sent over RabbitMQ in my job at the moment. And 2 jobs ago, I was working with the American legal system, and they have a government-mandated SOAP schema that they use for their internal things. But it's extensible, and they all extend it in different ways. And you know, Microsoft responded to this with WCF, which let you do SOAP without understanding anything about SOAP, in the same way that ASP.NET Web Forms let you make websites without understanding anything about the web. And then Douglas Crockford came along and went, so the way we write like hard-coded objects in JavaScript, we could actually use that as a data transmission format. We could send that over the wire. Things could send that down to your front end, and, bless his heart, we could use eval to turn it into an object. And so I was kind of, yay! And then people started putting really, really bad things in stuff that ended up inside a JSON object, and so JSON.parse was invented, and eval stopped working on it. But yes, JSON, it's a lot better. You know, it's much less, the ratio of data to craft is a lot lower. And so, yeah, JSON's quite nice. Let's just make APIs where we send JSON over HTTP. But no, then Roy Fielding, who has blocked me on Twitter, he really has. Roy Fielding came along, and Roy Fielding wrote a doctoral thesis. And in his doctoral thesis, he kind of went, you noticed how the web works? It's kind of cool. You send a request and you get a web page back, and the web page has a bunch of links in it, and you can click any of those links, and you can navigate the entire internet just by clicking these links, just using this application that understands the data that is coming back from the web server, which was probably exaggerating at the time, because when he wrote this, that was Internet Explorer 5. But still, the point was kind of valid. And it was just this, it was like a pain to the wonder of what Tim Berners-Lee had created. And a bunch of people went, yes, that's how we should build APIs. And what Roy Fielding should have done in that moment was go, no, it really isn't. It makes no sense. Because the reason that REST works for the internet is that it's going through our brain, and we are able to adapt to new information very, very quickly and easily, because if we weren't, we'd be dead. And so we make a decision about which links to click. This idea that if you just put enough metadata information, if you just turn that JSON that was like 80% data into something that's back to 15% data because you filled it with rels, then you can't write an application that responds to that. The best you can do is go, I can change the URL that represents a document, and the application will not need rewriting. Whoop-de-doo. Maybe don't change the URL, and then you won't need all this other stuff. And so then there was this whole thing about, I'm doing REST. No, you're not doing REST. That's just JSON over HTTP. I think we've all agreed now that REST is just JSON over HTTP. We're not worried about fielding anymore, except these people. Every time I see that word, it's kind of like hate OAPs, hate old age pensioners. And it's kind of like, it's not their fault. They're old. They're moving as fast as they can. And yes, they take a long time at the post office counter, but that's the only conversation they have every week, because they're children. Anyway, but no, in this context, this stands for hypermedia as the engine of application state. And this was where, like, the hardcore REST people went when the REST people started to relax a bit and go, yeah, okay, maybe just call it REST, and we don't. These people are like, no, and it got worse. Meanwhile, SmartBear and then various other people, and then it became an open standard, invented this thing, which is OpenAPI, where you just write a crap load of YAML that describes your system, and then things can come along and they can use that YAML to generate clients to talk to your system, which you cannot do with a RESTful system, because the URLs are multi-changing and dynamic, and they're not actually laid out anywhere. So how do you write a client? You have to know what the link is called. It's just, yeah. OpenAPI, for all its many faults, and it has faults, you can't have multiple operations on the same URL with the same HTTP method, which you should be able to do. You should be able to go, if I post text, it's an update to my bio. If I post an image, it's a new avatar. And those should both be on the same URL, and that should work. There is an OpenAPI 4.0 which will fix that if they adopt it. Or there's gRPC, which has multiple advantages. It's got the protobuf definition language. Anyone can take this and generate a very, very, very high performance client in any of the currently used languages. It's smaller over the wire because it's not human readable. It's the minimum number of bytes to get that message across. And because the serialization code is, so the format is optimized for fast serialization and deserialization. They've made decisions about the byte layout based on that. And because the server stubs and the clients are generated from this spec here, there's no runtime reflection, there's none of this sort of stuff. It's all just pre-coded and it's fast. That works as well. So yes, that is simple for APIs. If you want JSON over HTTP, that's fine. That's probably the default. If you need a bit more performance, or if it's between services in an internal network, then I would be looking at gRPC. Both of them are fine. Handwrite your OpenAPI spec. No swashbuckle, no nswag, no thing that Microsoft have replaced both of those with, thereby killing 2 more open source projects in .NET 9. It drives, I do a whole talk about this. It's a spec. It's what your system should look like. When we were building those systems with the sort of 80 by 23 characters and all this sort of stuff, we were using systems like SSADM and Prince2. You would essentially get specs that included pseudocode, the kind of specs where you're kind of like going, someone should just write a compiler for this, and then we wouldn't have to, then we'd have no jobs. and we go and live a pastoral existence on a mountain and arm ourselves heavily for the coming apocalypse. But yes, what we really wanted was specs that you could like lint, that could be checked, that would compile. And then OpenAPI comes along and it is a spec that can be checked. It can be kept in source control. It can have revision control. You can do pull requests against it. And then you can actually use it to validate that your application does what your application is supposed to do. If you generate it from the code and the code is broken, all you have is a JSON or YAML file that accurately tells you that your code is broken. Yeah? Don't generate your thing. All right, here come the reds. So yeah, we went from 80 by 23 characters to CGA and then EGA and then VGA and then 3DFX graphics cards and Windows 3.11 for work groups and Windows 95 and all these different things. And along the way, we came up with lots of different ways of creating user interfaces like Power Builder and Visual Basic and Visual C++ and C# Windows Forms and VB.NET and C# and WPF. And now there was Xamarin and all these sorts of things. But the web is where the majority of applications are deployed these days. And it used to be so simple. It used to be, anyway. We used to have a program that ran on the server, and you said, I want to see this, and it would pull the data and then wrap a few XML-ish tags around it and send it back down to your browser, and it would display a lovely web page. And then people decided, no, I don't like that, because, far as I can tell, it was the idea that the page refreshed. And so if you'd scrolled like a little bit down the page and it refreshed, then you'd be back up at the top of the page. Actually, browsers came up with a sort of hack to stop that from happening if it worked out that enough of the page was the same, but it was too late because spars had already been invented. And I don't mean this kind of spar. Wouldn't that be lovely? No, I mean single-page applications. Who is currently building, maintaining, supporting, or regretting a single-page application? I mean, I'm creating a single-page application that exclusively runs in Electron, which is just really weird. But no, this is how we are supposed to build front ends now. This is what we're told. You don't actually see quite so much of it at NDC conferences and so forth. The Java conferences, they love Angular, which makes sense because you think of all the boilerplate around building a Java application, and then you go, Angular, you've reinvented COBOL in JavaScript, well done. So yes, and I don't care which one of these you're using, or if you're using something else like Svelte, because Svelte was a nice way of doing tiny little DOM twiddling things to elements. Now it's Svelte Kit, and it's an entire way to build websites and everything. So yes, I work very, very, very hard to avoid ever having to type those two words, because I don't care how powerful your machine is. That's taken a while, without many status updates actually, because I run it earlier today just for testing for this talk. This is the output from it. This is what you want when you're building your system, is to be told that this is running against a React Redux app that has been generated using the npx dgit and the URL that is specified as the best way to create a starter application on the React Redux website. And you've got 1, 2, 3, 4, 5, 6, 7, 8, like a dozen deprecated packages in there, because JavaScript moves fast, man. NPM moves fast. That string padding library is gone. Anything that depended on it is now also gone, because they didn't vendor their dependency on 2 lines of JavaScript. And you might be going, well, what is the solution to this? It's really, really very simple. Stop using fucking JavaScript. Just stop. Thank you. But yeah, this is an empty application. This is an application that doesn't do anything. NPM has downloaded and installed and done whatever NPM done with 604 packages, and it's audited 605 of them, which is really clever. I appreciate that. You can never over-audit. Somehow it's 140 megabytes. That's just the node modules folder is 140 megabytes, although it is taking up 188 megabytes on my disk, mainly because of those 604 NPM packages. Quite a lot of them are going to contain a ton of files that are less than the smallest block size on the disk. And so they're taking up an entire block where actually inside it probably just says npx start. For comparison, I saw this in Dylan. I watched Dylan's talk in here, same slot yesterday, and he had this, and I was like, can you send me that image, because the Wayback Machine is currently down, and so I couldn't find it myself, and he sent it to me. This was Quake. This was the first true 3D game. It supported 3D FX graphics cards and all this sort of thing, and it was distributed as shareware, and I just love it, because it says, it will fit onto 1.44 megabyte floppies, and there are 7 zip files that you downloaded and extracted onto each of these 1.44 megabyte floppies. Alternatively, you can download one huge, this is why I wanted the mic, one huge zip file, 8.5 megabytes. 8.5 megabytes, the whole of Quake, all the music, all the levels, all the textures, everything that was needed to make this game that I remember it took a week of this was peak gamer time for me. I was 19, 20 years old, and a week to complete this game in the single player mode. And then many, many happy hours spent playing deathmatch on the Office network with the PCs they'd installed there so we could build much more complicated client-server systems, and bringing down anything that was trying to talk TCP/IP at the same time as you're running Quake, because it used IPX. Brilliant. But yes, can you honestly say that in order to display, let's say, the login page of your single page application, that the browser has to download less than 8.45 megabytes, 54 megabytes? Because, if you're using Angular, if you're using React and Redux and whatever else you have to throw at React to turn it into something that any sane person would even consider using, at which point no sane person would consider using it anymore because it's got stuff all over it, there are websites that have to download 10, 12 megabytes of stuff. They download a single thing and a spinner in the middle, which is probably using 0.5 megabyte of CSS, knowing these people, just to tell you that the site's downloading and could you wait a minute? And you're like, and it's all of them. They all do it. And then this is where this goes completely off the rails. Every single one of these, all of them, SvelteKit, don't care what it is, all of them invented server-side rendering. That's what we were doing. That's what we were doing, and it was fine. Roy Fielding wrote a doctoral thesis about how good it was. It was brilliant. Ask yourself, right, if you just generate static HTML with some CSS and some links, how many times Could your user browse to a new page within that application and do a thing that needed to do and find out a thing that they needed to find out before the sum total of the HTML that you have sent over the network exceeds the size of the Angular 18 runtime? Yeah? Not to mention that if you do this server-side rendering with any of these JavaScript frameworks, it comes with one pretty big caveat. You have to be running your back end on JavaScript. You have to be running Node.js or jumping through ridiculous hoops. And we're jumping through these hoops. Why? Because job adverts say React necessary. And so we're kind of going, oh, if I leave this job, I won't be able to get another job if I don't know React. Therefore, you say I have to add a thing so that customers can rate their sprockets. The auto mechanics go, oh, best sprockets in southwest England these are. And you go, I'm going to do it with React and Redux and Nuxt.js and everything else. And just stop it. You know what's really good is ASP.NET Core MVC. Controllers and views, or Razor pages. They've kind of muddied the edges now, so you can use Blazor components all over the place. Blazor components are much better than ASP.NET Core MVC's partial views and so forth. So I either dive into it straight away or wait 5 years till Microsoft burn it all down and launch it again with a new name. Razor pages, I know a lot of people like Razor pages. I spent too much time building stuff with controllers and views, and I can't get my head around Razor pages, so I don't. But they're fine too. And then that thing about scrolling and stuff. So yeah, you could download the entire runtime for something that was designed to build Facebook, and then all the other things that make it usable for engineers who aren't good enough to work at Facebook. No offense, neither am I. You could do all of that. Or if you want to do an update of a little bit, refresh a grid on the page, it's not even XML HTTP request anymore, which was quite complicated. It's just fetch, await, fetch, and then get a fragment of HTML, get new HTML from the server, and then just replace the DOM element. That's literally it. It's 3-4 lines of JavaScript. And if that's too complicated, you can use HTMX. This is not a sales pitch for HTMX, but I'm trying to say how simple is as simple as possible. And as far as I can tell, that's pretty much it. It's a tiny, it's like 18K of JavaScript or something, and it lets you do that, do a round trip to the server, just get a fragment of HTML back and update the DOM somewhere with essentially just attributes on your HTML. So, and you can write a little bit of JavaScript if you need to. I'm going to switch to a browser for a minute, and I hope I don't have anything too embarrassing on there. There you go, dgit. That's embarrassing. This is a website I made to help me learn the bass fretboard. This is a standard bass fretboard. This is a C major chord. See how fast that runs? That's it. It's sending HTML. There is a tiny little bit of JavaScript. There is one hand-rolled bit of JavaScript in there where if I click, I haven't got my glasses on, where the hell am I? There we go. If I click one of those Cs, it'll highlight the rest of the notes on that scale. That's all it does. And I was kind of like, oh, Blazor now does server-side rendering and this and that and the other, and you can use components all over the place. And I swear to God, I had started and got quite a long way down porting that site to Blazor. And the reason? So it would do server-side rendering until the WebAssembly runtime had downloaded, and then it would switch to just running on the client thing, where the only interactivity that I have thus far implemented is that you can click one of the notes and it will show you the rest of that scale where you would play it. So I've scrapped that, and I'm now just sprinkling a little bit of HTMX inside what I've already built. But yeah, server-side rendering, just Java server pages, Python, Django, I don't know, I don't care. Anything but React or Angular or Vue or JavaScript generally. we should be trying to forget that JavaScript happened. We've got WebAssembly now. We don't need JavaScript anymore. Okay, infrastructure. This is really fun. I've seen a couple of infrastructure talks so far this conference, and there's all sorts of brilliant stuff. Infrastructure used to mean like purchase orders being signed off in triplicate and then mailed somewhere, and then 9 months later a man would turn up with a very, very heavy crate. Whereas now, it involves writing a chef, no, wait, Terraform, no, what are we doing now? Pulumi. No, there's a different thing now. There's one that's just launching that's going, are you sick of all the YAML? And it's a graphical user interface. And I was going, how do I check that into source control? Who's using Kubernetes? Keep your hand up if you actually need to be using Kubernetes. So why are you using it? The thing is, the vast majority of us don't need to be running Kubernetes. We don't need the cost of running Kubernetes. Oh, but Mark, you say, we're not actually running Kubernetes. We're using AKS or EKS or GCS, GKS. I don't know. They generally have Ks in them. And then you're going, oh, so this is brilliant because I can deploy a service really easily. All I have to do is define the container and then the pod that the container is wrapped in, and then the service that registers it with Kubernetes DNS system, and then I need to inject secrets from the Kubernetes secret system, which is actually just proxying to Azure Key Vault because I'm running in AKS, and I have to do all these things to get my application up and running. And then I don't have to manage the Kubernetes itself, except you do, because they support each Kubernetes version until a third version comes out, and then that one gets rolled off. And if you're still on it, tough luck. So you have to upgrade. And then you have the choice of kind of going, what are the breaking changes? What APIs have they deprecated? What have they obsoleted? What's not there anymore? What doesn't work with this tool that we've been using for the last 3 years, and what can we replace it with? Does Linkerd work with this version, or do we have to switch to Istio? You are still managing, if you're using Kubernetes, you are managing Kubernetes. And then people go, oh, serverless, and as AWS Lambda, and this idea that serverless, we literally just take functions, and Microsoft called it Azure Functions. This idea that you can just write a function and throw it at the cloud, and then it'll run it when it needs to. Isn't that brilliant? As long as you have wrapped that function in all the attributes and the project type and the compilation and build and deployment process that you need to get that function into the cloud, and as long as you have used the SDK that is required to build applications that work with that system, and if you ever want to go to another serverless system, then you have to rewrite everything because it's a completely different SDK, and you forgot to keep your business logic separate from the bit that references the Azure Functions SDK. And then people kind of go, well, this isn't very good, lots of vendor lock-in, it's not very portable, how can we fix it? And they invented Knative, which runs on Kubernetes. Again, going to what's the simplest thing possible? So the thing is, Docker and the whole idea of containers, the Open Container Initiative, this idea of an immutable file system that's layered on top of the one underneath and can't change that. All really, really good ideas. Containers are absolutely brilliant. And Microsoft and Amazon and Google and most of the smaller sort of DigitalOcean and these things, they now have a system where you just go, here's a container image. If you wouldn't mind, could you set some environment variables to these values and just run it when a request comes in? And then shut it down. And if you do this, Azure Container Apps, completely brilliant, almost certainly cheaper than running your own Kubernetes cluster with at least 5 nodes, because you need at least 5 nodes for the 9.99 SLA to kick in. And they need to be quite chunky things, like 4 or 8 cores. I'm not sure what the spec is at the moment. Or you can just take a container and go run that. If it runs out of CPU, run another one. When they're not doing anything, shut them down and stop charging me money. And it works really well. And if you create a minimal API application, say, in ASP.NET Core, you can AOT compile that. It literally starts up in 0.001 of a second or something like that. And you can do that, and it can serve a request, and it can shut down again. And your end user's going to go, God, that was quick. Or the same thing with gRPC. Stick it in a container image, push it at a registry, tell something somewhere to run it when somebody asks for it. That's all you need to do. This, by the way, the website, this website that is insanely performant and clever. And the drop-down doesn't work. Yes, look. This is jazz. The modes, the Phrygian mode, the Mixolydian mode. And then I can kind of go, oh, look, there's my scales and all this sort of stuff. But yeah, so that website, I promise you, is running on a Raspberry Pi in my house. Not even entirely sure where it is. It responds to ping, the website's up. It's there somewhere. It's a Raspberry Pi in my house. I've got a Cloudflare tunnel. It's actually running in Kubernetes. Except it's running on a single node K0S cluster, which is the simplest possible Kubernetes. And honestly, the main reason it's doing that is because it was easier to set up auto-update. So there are 3 services running on this one node Kubernetes cluster. One is FretBadger. Actually, there's a couple of other sites running on there, but for this purposes. One is FretBadger, one is the Cloudflare tunnel agent, and the other is a single API, single endpoint API, which has a webhook, which when I push a new image without a preview tag on it to my registry, my GitHub registry, triggers a webhook, automatically upgrades to the new version on a Raspberry Pi that, seriously, I haven't had to touch it for so long, I'm not sure where it is. It's connected over a power line Ethernet cable. External services, this is the other place where we have a lot of fun. And so this is the stuff that's kind of like built into the platform. And this is my favorite example of this at the moment, Azure Cosmos DB. Azure Cosmos DB is a marvel of engineering. I mean, it is the pinnacle of this kind of thing. And some of this kind of thing, by the way, is installing PostgreSQL with the Citus Hyperscale extension and calling it PostgreSQL for Azure Cosmos DB. But never mind that. But you have this one database system that will look like MongoDB and work with the MongoDB SDK, and it will look like a SQL box. It will store JavaScript JSON documents and index into them and all this sort of stuff. It'll do Gremlin, which I think is something to do with graph databases. Yeah, good. It's always good when your audience is going, yeah, no, you are right, well done. All these different things. And people they go, oh, running in Azure, we use Cosmos DB. And then they go, why is Cosmos DB costing us £45,000 a month? I mean, I could understand if we were in production. True story. The reason for that, by the way, is when you have, because of law, you are legally required to store the complete content of any requests that you send to an external service and the response that you receive back, including the headers, in somewhere so that it can be audited. And you have some maybe a bit more junior developers who just go, oh, document.original request equals this, document.original response equals this, and then store it into your Cosmos DB database. Not indexable or searchable in any way. Some of it's XML, some of it is weirdly gRPC encoded as base 64 on the basis that if you need to decode it as part of an audit, you probably might be able to, hopefully, I don't know. But yes, and some of it JSON, but it's just blobs of data. And we're kind of like, how do we save money on this? I don't know. Maybe store blobs of data in blob storage, and then just put the URL in this thing over here. and get that down from £45,000 a month in UAT to I think about 1,500 a month in production, and wonder to yourself if actually maybe you should charge your customers like half the money they save you. I save them over that first year or something. That would be profitable. Quite a lot of the time, all you need is a SQL database. Simple SQL database, Postgres, Microsoft SQL Server, MySQL. Not Oracle. Never Oracle, obviously. Actually, the reason for that is that back in 1990, there were two database companies, Infomix and Oracle. They were the only ones that mattered. And Infomix is now a part of IBM, in the way that the sandwich I had for lunch is now part of me. That's funny, I'm going to write that one down. There are a surprising number of sites that are out there that the database they're actually running on is SQLite. And what they've done is they've created a server around SQLite that takes care of the fact it's essentially just a single file database and doesn't have any multi-user capabilities. And they just kind of like, well, just put a little thing around it. And then this web server and this web server and this web server can all store things in the same SQLite database. Works perfectly well. It's still more complicated than a text file. So I'm building a thing at the moment, and it is literally sort of moving blobs of data around, and then each of the blobs of data has some metadata attached to it. And I'm kind of like, well, I could, and this is all cached on your local device, be that a phone or a desktop machine or whatever. And I'm kind of like going, oh, I could use LightDB, that's quite good. That's an embedded document database, or I could use SQLite. And then you're kind of like, or you could just call JSON.serialize to a text file, because the volume of data per user that they're going to have on this thing, this is an ephemeral system. Data lasts a maximum of 7 days, then it's gone. Even if I do need to go searching through it, I can open half a dozen files at a time and search through them all, however many cores I've got on the machine. I don't need to introduce more complexity into my project to achieve this. I can just text files. And then there's the process that we use to try and excuse the fact that we're doing all of this, and which may go a long way to explaining why we do all of this. Because the 90s, we had SSADM, we had Prince2, we had various other things. They were essentially like those ships where up on top there's people kind of going, yo-ho, and a bottle of rum, and then down underneath there's a bunch of miserable people being whipped to within an inch of their lives, rowing the thing. And we called them software developers, and we gave them specifications and 4 weeks holiday a year. And Waterfall was brilliant, because it predict everything, and you go, yes, we are definitely going to be doing this thing down here, precisely this amount of time, after we've done that thing up there. I've planned the whole year out, aren't I clever? Then, Kent Beck, who was speaking, did the opening keynote here, and a bunch of other, let's face it, probably some of the best engineers who have ever engineered, got together in a room and said, we don't need all that. We're awesome. We can just make it up as we go along. And the thing was, they could, because they were awesome. And I know we, obviously, in this room, we are all awesome. We could totally do extreme programming. Unfortunately, the world does not have a sufficiently large supply of awesome people that your company is able to staff your development department entirely with awesome people. So you've got Steve. Steve can't do extreme programming. Steve can't even pair with people because he has an odor. So we invent Scrum, because you don't have the self-discipline, don't have the knowledge, don't have the power. So what we'll do is we'll get someone who's actually going to be using the product. We'll call them the product owner, and they come over here and they go on a team. And then we'll get someone who can organize a piss up in a brewery, because you lot can't, and then we'll call him the Scrum Master. You're the lead developer, but essentially the structure here is flat. And we're going to kick off a 2 or 3 or 4 week period, depending on how badly we're fucking this up, with a full day of meetings to groom the backlog, and then we'll have a sprint kickoff meeting where we say what the goal is going to be, and we've decided how many points each of these things is going to have. By the way, the points don't have any relation to how long it's going to take, but you did 180 points in your last sprint, so if you don't do 180 points in this sprint, we're going to have a meeting about that, you better believe it. Then at the end, we're going to have another meeting that takes a whole day where you explain why you didn't get anything done. And actually, a big part of the reason why you didn't get anything done is that now we're doing the daily stand-up, sitting down over Teams from our houses, and so nobody cares that it lasts an hour and a half. Because you can actually bugger off and make yourself a cup of coffee and just, oh, he's turned his camera off. He's gone for a poo. You need some kind of organization. As far as I can tell, this is the simplest one. It's kind of like, here's all the things we have to do. I am currently doing this one. Here's all the things we've done. And you can just kind of decide between you as you go, what's the most important thing that I can do next? Or which of these things can I currently do, given the things that we have already done, that doesn't depend on any of the things that haven't been done or are still in. But yes, cards. Yes, writing things on them. Yes, sticking them to a wall. I suppose, given that I really don't want to go back to working in an office, yes to browser applications that use JavaScript to simulate pieces of paper sellotaped to a wall, but if we could not do that, that would be great. Maybe some kind of virtual reality thing. But yeah, essentially, this is what you're doing now. That's what you're doing next. And then there's a big list of things here that you're going to do later. And stop pretending that you can estimate how long anything is going to take you. Because A, that's really difficult, and probably Bayesian inference and that sort of thing. And B, we suck at it. We cannot do it. Engineers can tell you how long it will take to build a skyscraper. We can't tell you how long it will take to build a login screen. Just stop pretending that we can, grab a story, do it well, stick it on the other side of the board, and then go, right, I'm going for a beer. And just keep doing that until you've built a system. And if you've got junior developers, review their code and coach them and teach them how to write clean code and all this sort of thing. And because, So, in summary, professional, proper technical talk, imparting information. Have a summary at the end. Do the minimum possible to make something work. Use the smallest possible number of components and moving parts, and you will build something that is robust and reliable, doesn't break, and that you can come back to in 6 months and go, oh, I see what we did, and fix it. Use the simplest solution for any of your problems. If you need a database, will SQLite do the job? If not, then PostgreSQL. If not, then Microsoft SQL Server. If not, then probably Cosmos DB or some other big cloud-hosted thing, or a completely different kind of vector database, because I'm doing AI. Don't even get me started. Building a website, render HTML on the server and send it over the network. The browser will render it for you really, really fast. It's amazing. If you need a little bit of interactivity on your web page, write a little bit of JavaScript. Don't download an 18 megabyte runtime. Wrap your application and all its dependencies in a Docker image, fire it off into the cloud, and say, please run that for me until I send you another one. If you do need to add complexity, if you need to break something out of your clean code monolith and rip it into another microservice, you do that when it's necessary, as it becomes necessary, as you start to face the problems that those solutions were intended for. When your Azure Container Apps hosting bill has gone so sky high that it is actually cheaper to hire somebody whose full-time job is to keep a Kubernetes cluster running smoothly, but only when you need to, okay? And if you think you need to, you all should sit down around a table, and some of you, despite the fact that it might be somebody going, I think we should use super Kubernetes. It's like Kubernetes, but better. And you're there going, that sounds awesome, I want that on my CV, that's going to be brilliant. But no, one of you has to just do essentially, you know the Monty Python sketch, is this the right room for an argument? I told you once. That, just immediately contradict anything the person who wants the thing is saying, and if they can get through that, then go, yep, all right, you can have Super Kubernetes. And stop introducing complexity into software projects so that you can put a technology or a skill or a process or something on your CV. There is a sufficient elapsed time between them saying, AI liked the look of your CV and forwarded it to a human person who went, oh, that's a nice font, we should get them in for an interview. I like what they've done with their name and that letters. You've got about a week, probably, sometimes more if it's one of the big companies. If you've said you know React and you've never used React, but you know JavaScript, and you know web, and you've done Angular, or you've done Vue, or something, or you've just done a bit of JavaScript, then just on your CV say, yeah, I know React. Because the thing is, it's not that difficult. It's ridiculously complicated, far more than necessary. But actually what you should be doing is lying on your CV, saying you know React. If they give you an interview, learn enough React to get through the interview, and then on your first day, I want you to walk in there with an axe that has clearly already been used and say, right, let's get rid of React. That is all I have time for. I only went 6 minutes over. Thank you very much. That was the response I was hoping for. Go and get yourself some beers. Fun talks are starting in the big room in a little while, and I'll be doing some stuff later. And have a great evening. I'll see you around.